In today's lesson, we are going to be looking at patterns to rules. Now, this may have been something that you've done quite a bit of in elementary school. We're going to use this as kind of an introduction to our linear relationships. So again, the goal is to be able to look at a pattern or make a connection between a pattern and a relationship using equations. So we're going to look at certain patterns, again, figure out how to represent them as a rule, and identify kind of a common theme to those patterns, or a general form to those patterns. So as a warm-up, looking at the input, so if I input these numbers into the robot, they follow a rule and give me an output. So we want to think about, what is the rule? What are the robots doing to the input numbers to get the output numbers? Now, you might be able to look at the input and the output right away and be able to figure out what the rule is, or it may take some time, it may take some trial and error with a calculator, which is okay. But if you take some time and think about it, you should find that the rule is that you multiply by 7. So we can see 2 times 7 is 14. 3 times 7 is 21, 4 times 7 is 28, and so on. So that is our rule for this one. The next example, now we have some gaps that we need to fill in. So we might need to figure out what the rule is first and then fill in our gaps. So again, thinking about what the rule is, 2 becomes 16, 4 becomes 32, 8 becomes 64, 6 becomes something, and then something becomes 80. Now again, it may take some trial and error, or you may be familiar, or you may be able to pick up on what the rule is right away. But again, if you take some time to think about it, you should find that the rule is multiply by 8. So if we're going from the input to the output, 2 times 8 is 16, 4 times 8 is 32. We can now fill in this box because 6 times 8 is 48. So we can fill in our box here. And now, how do we figure out what the input is? Now, there's different ways that you could go about doing that. You might be able to intuitively know what you multiply by 8 to get to 80. But if you don't, you can always go in reverse. So if I reverse my rule and go backwards, I would do the opposite. Divide by 8. Similar to what we were doing when we were solving equations. We were doing the opposite operation to kind of work backwards or to cancel things out. You could do the same thing here. Opposite of multiplying by 8 is dividing by 8. So 80 divided by 8 is 10. And again, you might have reasoned through that anyways to figure out, or you might have already figured out, well, I multiply 10 by 8 to get to 80. But if not, you just reverse the rule. The next question. Again, same idea. Figuring out what is the rule going from the input to the output. I want to think about, what is the rule? If I look at them, you might be able to say, okay, well, looking at 1, 1's an easy one. 1 times 6 gives me 6. That's an easy one to check. Let's see if that rule works for the other ones. 2 times 6 is 12. 3 times 6 is 18. So that doesn't work. So it might require, again, this one might require some more tinkering with, or more playing around or trial and error. And we will look in the future at more concrete ways of how to figure out the rule. But for right now, just want you to try to think about it, play around with some numbers, and see if you can get the rule. If you've taken some time, you should find that the rule is multiply by 5 and add 1. So going from the input to the output, now we have two parts to our rule. We multiply by 5, and then we add 1. 1 times 5 is 5, plus 1 is 6. 2 times 5 is 10, plus 1 is 11. 3 times 5 is 15, plus 1 is 16. So again, this rule does work. Lastly, we have another one, or not lastly, but we have another example. 2 becomes 24. 4 becomes 38. 6 becomes 52. 8 becomes 66. And 10 becomes 80. So right off the bat, you might say, oh, 10 and 80, I saw that before. Multiply by 8. Well, 2 times 8 is not 24. 2 times 8 is 16. So we know multiply by 8 isn't the rule. So if we know we can't multiply by 8, we could multiply by a larger number and have to subtract, or we could multiply by a smaller number and have to add. So now this comes down to a little bit of trial and error. So what could we multiply by, and what could we add or possibly subtract to get our output? And when you take some time to think about it, you should find that the rule is multiply by 7 and add 10. So going from the input to the output, the rules that the robot are following is we multiply by 7 and then add 10. So that is our rule. So again, that one was a little bit trickier and may have taken a little bit longer, but hopefully you're able to work it out. Now we're going to look at more of a pattern. So while the other one was a pattern of numbers, this is more of a pattern of blocks. So it might be a little bit easier to visualize it. So what would be the fourth position? What would the shapes look like in number 4? Hopefully by looking at the tiles you could see the pattern. This one shouldn't be too hard, but for number 4, maybe it's a little bit too large. Make it try to be fairly accurate. We would have 4 rows of 3. So that means we start off with 3 tiles, 6 tiles, 9 tiles, 12 tiles. So even though we visualized it, this could still be represented as an input-output kind of pattern or kind of problem, with input being 1 and the output being 3, 2 and then 6, 3 and 9, and so on. But we're just visualizing it as a pattern, or as a visual pattern. So our rule in this case, you'd say the step number, which is, or position number. So step number times 3. Or you could say step number multiplied by 3, or any sort of variation that kind of represents that. You could just say multiplied by 3. That would work as well. The second one, again, this one might be a little bit more difficult, but hopefully by visually seeing it, we can come up with what the pattern should be. So by going through this, you might recognize, okay, I see something that kind of remains the same. And we see some things that are changing every step. Oops. So we see that we would add in another row of blocks, while the diamonds, or the blue blocks, stay the same. So again, that is what our next pattern would look like. And again, if we wanted to, we could represent this as an input-output. So we have 1, 2, 3, 4, 5, 9 blocks. Yes, they're different colors, but in general, we have 9 blocks. Then we have 14 blocks. Then we have 19 blocks. Then we have 24 blocks. So again, we could represent this as an input-output, with our input being down here and our output being up there. So, but again, we're just representing it visually now. Again, if we wanted the rule, we know position 4, what it looks like. The rule, hopefully again, now that it's visual, it's a little bit easier to see the rule. You'd say step number multiplied by 5 plus 4. So 1 times 5 is 5, plus 4 is 9. 2 times 5 is 10, plus 4 is 14, and so on. And hopefully you see the connection between the actual visual and our rule. We see that what we're multiplying by are these red blocks that change, and what we're adding are these blue blocks that stay the same. So that's going to be important to recognize what stays the same and what changes. Let's look at another example. So now I have a tile or a pattern, and I want to draw the 4th position. So again, looking at the pattern, hopefully we can recognize what's happening and what's staying the same. Oops. We can see we're going to have 4 blocks now with the 4 corners. So that's going to be position 4. Now let's come up with our table. So at position 0, I don't know yet, but position 1 I know for sure is 6, and then 8, and then 10, and then 12. So what would position 0 be? What would it be if I went back to position 0? You could think about what's changing every time and what's remaining the same. And if we're at position 0, then what remains the same should also be there. So we would have something that potentially looks like that. Just the 4 corner squares. So position 0 is 4. You could also argue, well, I'm increasing every time by 2. Every time I go up. But if I go backwards, I would be doing the opposite, or decreasing by 2. So again, different ways you can reason through it. As for the rule you might say, well, I'm going to multiply by 2 and add 4. Based on what we've done so far, that's the rule. Multiply by 2 and add 4. Now, when we're coming up with rules for these types of patterns, there is a general form that it follows. And that general form is y equals mx plus b. Or you might say, well, y equals b plus mx. Because it makes sense to start off with our constant. Again, either way works. But in our case here, this rule is going to be y equals 2x plus 4. Or again, you could switch those around, 4 plus 2x, which might make sense in terms of how the pattern grows. Because it's going to be for every pattern or every position number, we're multiplying by 2 and we're adding 4. So when we get to the number of tiles at step 41, what we're going to do here is this value here tells us that x equals 41. So in our case, y equals 2 times 41 plus 4. Now we've done this before with solving equations, so now we're just understanding that x represents the step number. Substitute it in, 2 times 41 plus 4. This is just a calculation that you can do on your calculator, and you get 86 tiles. So that means if I were to draw this out to position 41, I have 86 tiles. Let's look at another example. I want to go through the same steps. Draw the 4th position, complete the table, come up with a specific rule, and figure out the number of tiles at step 41. So I'm going to recommend that you pause the video now to try this one on your own. Again, create the 4th position, complete the table, come up with a general rule, put that rule into a mathematical form, and then figure out the number of tiles at step 41. So when we go through this example, we should find that our 4th position is drawn. We've completed the table. We've reversed our pattern to find out that at position 0, we have 5 tiles. Hopefully you could recognize that from the pattern, and that's what's staying the same. And in our rule, the rule is times 6 add 5. So if I put this into a specific mathematical form, it'd be y equals 6x plus 5. And then at step 41, or basically when we're saying x equals 41, we have 251 tiles, or y equals 251. So good. Hopefully you were able to come up with that. If not, again, let's make sure you copy this down. Now, as a summary, there's 2 key things that we're looking at when we're going through and coming up with a rule. The first is a multiplier. The multiplier is what the pattern increases or decreases by. So whatever the pattern is changing by or increasing or decreasing by, that's what we consider the multiplier. If you go back and look at the previous examples, when we drew the arrow from one pattern to another, that number that we were increasing by was the multiplier. So even though we were adding on a certain number of tiles in our rule, that's what we were multiplying by. And if you think about it, the larger the multiplier, the faster the pattern grows. The smaller the multiplier, the slower the pattern grows. You can think of it as, well, if it's a large multiplier, we're adding more tiles. If it's a slower multiplier, or a smaller multiplier, we're adding fewer tiles. So it makes sense in terms of how fast it grows. The multiplier is also called the rate of change, or ROC. And we will be looking at multiple terms for this. So multiplier and rate of change are 2 of the terms right away. But again, we will introduce more terms and definitions. The constant is what the pattern starts at, or you could also refer to it as what stays the same. If you look at those patterns that we referred to, the constant, what we're adding, that's what stays the same throughout. So we weren't changing it, we weren't adding it, or we weren't adding multiples of it. It stayed the same. Right? So those blocks or those colors, they stayed the same in every step. In a table, the constant value is the x value for an input value of 0. Or sorry, not the input, the y value. You say the y value or the output for an input value of 0. Which I'm going to put output because that makes more sense in terms of what we've done. So if we go back to our table and look at the input value of 0, or you could argue position 0, that is what the constant is. The output at an input of 0 or at position 0, that is our constant. In a tile pattern, the constant part is the part that stays the same in the pattern. So it's the part that stays the same. So we kind of mentioned that before. So again, those are the two key parts of any rule that we come up with. When we're looking at these types of patterns or relationships or rules, we're generally going to have a multiplier or a constant. When we want to form a rule in a linear pattern, we write the rule in the form y equals mx plus b. So we've talked about this before, we've mentioned this. Now there's two key parts, the m value and the b value. The m value is what we refer to as the multiplier. Now it makes sense on a couple of frames. One starts with m is multiplier. Also, it is the only value that is multiplying in our rule. You see it's multiplying, or it's joined with this x, so it's multiplying. So m is our multiplier. We also now know it as our rate of change, or ROC. B, referred to as our constant. So B is our constant. We could also refer to it as when input equals 0, or more specifically, the output when input equals 0. So that was another definition for it. And again, we will be adding definitions as we go through. But again, for right now, for our general rule, y equals mx plus b. Again, as I mentioned, you could rewrite it as y equals b plus mx if you wanted to, because it might make more sense to you of we start with our constant or at position 0, and then our multiplier is what we add on every time. So again, however you want to write it is up to you. Taking what we just learned, so if you didn't quite get it or quite realize or recognize it in the first two examples, now we're going to go through and look at one more example, and hopefully it makes a bit more sense now. So now we want to draw the fourth position. So going to position 4, based off of the pattern, I want to draw the new pattern, or the new position number. So again, looking at it, we see that we're adding in another row of tiles. We have our diamonds, or kind of this rotated tiles in the corners. So that's our fourth position. Thinking of from the table, position 0, I don't know quite yet. Position 1, though, I can easily count and say there are 7. Position 2, there are 10. Position 3, 13. And position 4, there are 16. So if you go back to that pattern and take a look and say, okay, well, what am I increasing by every time? Or what am I changing by? That amount, so plus 3, plus 3, plus 3. That amount is our multiplier. So that tells me in our rule, y equals 3x. Or in words, we know that we're multiplying by 3. Now if I look at my rule, multiply by 3, that's not the entire rule, because 1 times 3 does not equal 7. 2 times 3 does not equal 10. So there needs to be something else. And if we look at our pattern, there is something else that we haven't taken into consideration yet. Our multiplier took care of this constant change, or this change. The other part are these 4 shapes, or 4 tiles that don't seem to be changing. So that part, let me just kind of color code things here. So that part that's not changing, that is our constant, or plus 4. Now we also mentioned that could also be position 0. So if I work backwards in my rule and minus 3, I would end up with a shape or a pattern that's just the 4 diagonals or 4 rotated triangles. And in my rule, or my table, position 0 would be 4. So we also mentioned that in our table, when the input number is 0, that is also the output is our constant. So we could see the plus 4 in other ways. So now going back to the last thing, the number of tiles. Again, step 41 tells us that x equals 41. So in our rule, y equals 3 times 41 plus 4. This just becomes a straightforward calculation, and we get 127. So that means there'd be 127 tiles at step 41. So again, the main things that we should be getting from this lesson is how to come up with a rule in words. Oh, we forgot to add the words down here. So multiply by 3, add 4. So looking at a pattern or an input, output, or a table, how can we come up with the rule, whether it's in words or in the specific formula y equals mx plus b, understanding what m and b represent, and then again how we can use that to figure out how many tiles are at a specific step. So the main thing is being able to recognize it in a visual pattern, and if you need to, you can put it into a table, and then using that specific formula as well.